Okay, so in this class we're going to look at showing an object is moving with simple harmonic motion when given the equation of its displacement or its position, and we can show that it's moving in simple harmonic motion. Okay, so remember, an object is moving with simple harmonic motion if and only if its acceleration is proportional to its position relative to a fixed point but has the opposite sign. And so here we have a particle moving in such a way that its displacement from a fixed point can be expressed as s equals 2 sine 4t, where t is the time in seconds. Prove that it is moving with simple harmonic motion. You know, we already do. As soon as we see that it's a sine omega t plus alpha, it's moving with simple harmonic motion. I know, for example, a is equal to 2, omega is equal to 4 here. Okay, so I can find all sorts of stuff with that information. But in order to prove it's moving with simple harmonic motion, I want to really satisfy this definition. So I'm going to find an expression for its acceleration. To do that, I'm going to find the second derivative of displacement. So first of all, we're starting with displacement, which is 2 sine of 4t. That's the displacement, where t is the time, so t is the variable here. The velocity will be the derivative of that. Okay? So we're taking the derivative with respect to t of 2 sine 4t. Okay? That 2, in fact, you know, good practice here to just keep that 2 factored out. So it's twice the derivative of sine of 4t. So the velocity will be twice. The derivative of sine of something is always cosine of that thing times the derivative of that thing. So the cosine of 4t times the derivative of 4t, well, that's going to be times 4. So simplifying here, that's just going to be 8 cosine of 4t. So that's going to be its velocity. That's an expression for the velocity of the object. It's 8 cosine of 4t. To find the acceleration, well, we know that the acceleration is just the derivative with respect to t of the velocity. And the velocity is 8 cosine 4t. So I'm going to keep the 8 factored out and take the derivative of the cosine of 4t. I'm going to get 8. The derivative of cosine is negative sine. I'm going to take that negative and put it here in front. So it's negative 8 times sine of the argument, 4t, multiplied by the derivative of the argument, which is just 4. Okay? So negative 8 sine 4t times 4. 4 8's 32, so that's negative 32 sine of 4t. So that's the acceleration. Okay? The key here is to understand that that acceleration can be written as negative 16 multiplied by 2 sine of 4t. So why did I factor out the negative 16? Because I wanted to get the 2 sine 4t, because that now shows me that the acceleration is negative 16 multiplied by the displacement. Okay? So the object is moving with simple harmonic motion. Why? Since its acceleration is proportional to its position relative to a fixed point, but has the opposite sign. Okay, so really you just write out that whole sentence now. It's moving with simple harmonic motion since the acceleration is some negative constant multiplied by the displacement. So simple harmonic motion since the acceleration is some negative constant multiplied by displacement. Okay, and that's how we prove that it's moving with simple harmonic motion. It also says find its period and frequency. Find its period and frequency. So from our tables, page 54, we know that period is always written as 2 pi over omega. What's omega? Well, omega is the coefficient of t in the argument here. So here omega is 4. In fact, s equals 2 sine 4t. The first two quantities I should be able to see of that is the amplitude is 2 and omega is equal to 4. So therefore the period, which we give a capital T to, is going to be 2 pi over omega. That's 2 pi over 4, which is pi over 2. T is the time in seconds, so the period is given in seconds. The other formula that's given in your formula and table booklet is just a definition linking T and frequency. Frequency is the reciprocal of T, and T is the reciprocal of frequency. Okay, so in this case, the frequency is going to be 1 over the period, which is pi over 2. The reciprocal of pi over 2 is just 2 over pi, and those are periods per second. Okay, so that's my frequency. 2 over pi periods per second. The period is pi over 2 seconds per period. Frequency 2 over pi periods per second. It's just the reciprocal. One is the reciprocal of the other. Okay, so that's how we prove simple harmonic motion.